My name is Marian Shoemaker. I'm in Group 5 that focuses on Dick's Sporting Goods, and this is Exercise 3. So within Exercise 3, there are two parts. The first part is Exercise 3.1, which focuses on data quality factors. So there are two factors contributing to poor data quality. The first one is completeness. So does this meet expectations of comprehensiveness? And then timeliness. So what information is available when expected and needed. So we're first going to look at completeness. So this chart right here is pulled directly from the Dick's Sporting Goods playbook and provides an example of how lack of completeness can result in poor data quality. So as specified in the second paragraph in this screenshot straight from the playbook, the data set was incomplete as a portion of the water and waste data from 2016 was missing. So this resulted in the greenhouse gas emissions results being inaccurate for the year 2016. So completeness quality measurement. So how would we measure completeness? So seeing the amount of data that is gained from each Dick's Sporting Goods. By doing this, we are able to obtain the most amount of data we can for each store and warehouse. Double checking and clarifying the data that is submitted. Some stores may not include certain stats or operations that may fluctuate the actual totals and percentages of waste for that specific store. So then our improvement plan for this is making a foolproof sheet that describes exactly what totals and percentages the stores are required to fill out, and then having a supervisor specifically make sure that the data being given is accurate and not skewed in any way. So then going to timeliness. Many data sets are delayed due to the volume of data being collected and then the reliance upon external open sources to get their data. So for our example in particular, the data set from the EPA only runs through 2018, with that year being the most recent information available. So this would factor into Dick's Sporting Goods' inability to collect some data points when running their analysis of GHG emissions in comparison with the national data that is out there. So timeliness is a measurement. So it can be measured by reporting year to determine the lag in external reporting practices from primary data providers. When comparing company data to national data, there will be a longer period of time for external measures than the internal measures. So the improvement plan for this, so a reasonable time frame set for data collection between various sources will aid in analysis expectations. Internally, information may be more readily available. Framing report times within the context of available external sources will provide more successful and realistic results in the long run. So then the second part of Exercise 3 is basically looking at data characteristics and then the distribution of said data. So this data profile and data types, we inputted our data into SAS Viya and ran it through. So as you can see, varchar is categorical data, and it refers to a fixed length character string. And then double is a base SAS numeric data type. It is continuance data, and then in SAS, double refers to a 64-bit double precision floating point number. So then going off of that, looking at varchar again, it is clarified further to detail that it is string data. So you can find varchar and data type and then go over to the actual type, and you can see that it is clarified that varchar is string data. And then, so there is missing data. Not all the data is given for the years leading up to 2010. So there are those missing points that we talked about earlier. So then data contribution. So when viewing the data using the profile tab, no pattern is really detected except for materials, which displays a numerical value of 16.